Okay guys, so welcome back again to another video. So in this video we are going to talk about the biosynthesis of naringenin. So this molecule is a one type of this flavonoids. Okay, if you have heard about these flavonoids, these are much useful in many cases, right? In medical, there are medical uses, there are industry uses, there are a lot of things. So one type of this flavonoid is this naringenin molecule. So we are going to talk about the biosynthesis pathway in this particular molecule. So we are going to start it with this particular molecule, right? So in this first case, what happens is we are going to add three molecules of this one. This is acetyl coenzyme, if you remember it, right? This is acetyl coenzyme. So when you have introduced this three molecule into our this chain, you will have this particular molecule. This if you are a little bit hard about like understanding how this molecule is going to be attached to this part, right? I highly recommend you to watch our polypeptide synthesis video. So we have talked about how this acetyl coenzymes, malonyl coenzymes, how these things cooperate, how these can react with each other. So we have explained it very well. So I highly recommend you to watch our polypeptides video. So you will have the better understanding about how this mechanism work, like how this molecule attached to this original molecule. So I'm not going to talk about this particular mechanism. So when our acetyl coenzyme is going to be when our acetyl coenzyme binds to this new molecule, we will have this little bit longer molecule. So I'm just gonna draw the same structure, little bit bent on it, right? So let me put some numbers to understanding. So let's say this is 1 2 3 4 5 6 7 8 9. So here you can see this is 1 2 3 4 5 6 7 8 9. So now you can understand it, right? So I have just drawn the same molecule, right? There are no difference between these two. I have just drawn the same molecules but I have introduced some bends. So it's easy to understand, it's easy to draw the arrow precision mechanism when we have it like this. And then what happens is a simple Claisen condensation, Claisen reaction. I hope you know about these Claisen reactions, right? These are basic reactions. Like if you are looking into the biosynthesis pathways, if you are learning deep into these biosynthesis pathways, these Claisen reactions, aldol reactions, these mechanism you need to know. So if you have no idea about Claisen reactions, I highly recommend you, before you go further into this biosynthesis metabolized reactions, understand those basic things. So when this Claisen reaction happens, in this particular place there are hydrogens. This hydrogen contains higher acidity. Why? It's because of these two carbonyl groups. So we can introduce a biological base to remove these hydrogens. Right? So when the hydrogen is being removed, you will have a lone pair. This lone pair has nucleophilic characteristics. So this lone pair can go and attack to this particular carbonyl group. Due to this attack, this bond will be broken. Now in the Claisen mechanism, right? In Claisen mechanism, this broken bond will be come back to form the pi bond again. So when that happens, this carbon will be unstable. So this carbon has to remove a one bond to get stabilized. So this particular part will be removed because it's a good leaving group. If you remember in the aldol condensation, right? In the aldol condensation, this broken bond will not go back to form a pi bond again. It will go and attack a proton. So in aldol condensation, you will have OH2. But in Claisen mechanism, you will have this carbonyl group back again. So here you can see the bond is being restored. Here you can see bond is being formed and our carbonyl group is being restored. Now we have these two ring structures, right? So let's move on. Now what happens is a simple enolization will be happen. Enolization. So what basically the enolization means is these carbonyl groups will be converted into hydroxyl group with introducing the double bonds inside the ring. So here you can see that those carbonyl groups has converted into hydroxyl groups. We have introduced double bonds like the pi bonds inside the ring. So this is basically the enolization. So in the next case, right, in the next step, a Michael addition reaction will be happen, right? So when this microaddition reaction happens, you can see there's a double bond in here, right? This bond will go and attack to this particular place and form the bond between this oxygen and carbon, right? So this here we have the microaddition product. So here we have our final product also. This is naringenin. So this is a simple molecule, right? This is a simple molecule, and also like again this microaddition, it's a different kind of mechanism, right? If you have not remember about it, go back and watch it. We have a video about microaddition too. So not that much hard. It's simple mechanism. So here we have discussed the naringenin, biosynthesis of naringenin. I hope it's okay. It's not that hard, right? It's the same old reactions. These are polyclinic reactions we have talked about in the first few videos of biosynthesis. And then here Claisen reactions, aldehyde reactions, enolization, NADP, NAD+. These are the general reactions we are going to come across again and again and again. So again, like I am telling in my previous videos, just take the understanding about these general steps, then you can easily find out, like you can easily understand the these kind of mechanisms. So I hope you are okay. If you have any questions, feel free to answer it. Feel free to put it under the comments. I will try to answer in my best. So we will meet in our next video.